Hello everyone. In this video, I'm going to review an electric ball valve. This new model recently appeared. It's very similar to this model here. I've already reviewed it before, and I'll leave a link in the description. From a distance, they look identical, but inside, they are different. The handles are different, and the way the valve connects to the actuator is also different. The valve is controlled by 220 volts, 50 hertz. It has a 3-wire connection. The yellow wire is neutral, and there are 2 phases, one for opening, the other for closing. Let's try to figure out which is which now. I don't remember. The thread diameters for these valves come in various sizes, from 1/2 inch, 3/4 inch, 1 inch, and perhaps even larger ones exist. I think you can find even larger sizes. This one is DN20. I took 2 identical ones and will connect them and compare how they work. The valve's actuator connection differs in that here we already have this metal mounting. This part is made of some alloy, most likely aluminum or duralumin, and it goes inside. In the previous version, the connection was plastic. That is, this splined piece where the valve attaches was plastic and molded together with the housing. But here, they made it separate. The housing simply attaches inside. This guide is metal, and the shaft inside, which rotates the ball, is also metal here, whereas in that model, it was plastic. And the manual override also differs from that model. Here, to turn, open, or close it, you had to press the handle and then rotate it. When pressed, the gear disengages and then the handle rotates freely. Here, they added this extra lever, and when the lever is in the horizontal position, the handle doesn't turn because this shaft is connected to the gearbox. If you lift the handle up like we're doing now, then it rotates. So the actuator is disengaged using this handle. If you leave it in the upper position, then the motor itself won't rotate the valve. Move it horizontally and the actuator engages. And let's connect them and compare how they work, because the motors inside are different. I've connected it to a remote switch. Button A opens the valve, it's open. Button B closes it. And in terms of time, it operates much faster than the previous model. Let's time it, and now let's compare it with the previous model. If this lever is left in the upper position, the motor will just keep spinning and will never turn off, because the limit switches are located on this shaft along with a ball, and they shut off the motor. Then when we leave the handle in the upper position, the motor will continuously spin and won't turn off. That is, it will turn off if you manually rotate it, and the limit switch switches the relay. I disassembled one valve to show how it's constructed inside. There are 4 screws here. They are unscrewed. This top handle is removed. It's difficult to remove because it's also glued on so it doesn't come loose. And the lid comes off upwards, like this. Here we have the control board. Here are 2 limit switches. The shaft, when it reaches its extreme positions, presses the buttons, on one side and on the other side. And it shuts off the motor. It stops rotating. 2 relays, a 220-volt transformer. Here we have a low-voltage motor, a small one. It's located under the board. All the gears in the gearbox are metal. But I won't disassemble it further, because if this cover is unscrewed, the gearbox will fall apart, the gears will fall out. But they are all metal and lubricated. This lever lifts the gear, that is, it's fixed on an axle and spring-loaded. When you lift the lever up, the gear lifts and disconnects from the motor. This is how this model of the valve is designed. I will leave a link to it in the description. Thanks everyone for watching. Bye everyone.